Section 8.1 Radicals. The square root of 25 is equal to 5 times 5, and when you have a square root, there's a 2 inside the root symbol that you don't necessarily see. But when you have two 5s, you're looking for 2 of anything to take something out. So basically the square root of 25 is 5. And on your calculator you have a square root button. So if you put in the square root of 25, you would see 5 come out on your calculator display. So the first few problems you will be using your calculator, so make sure you know how to use the square root button. If you have a negative in front of the square root symbol, it means that when you take the 5 out, because the negative is on the outside, it's okay. The answer would be negative 5. But if you have a negative inside, this is not a real number. You can't do this one. And I believe in the computer they want you to type in D and E. So what happens if it's not a perfect square root? If it's not a perfect square root and you're doing it on your calculator, you're going to see some decimal points. So most of the problems, if it doesn't say use your calculator, they want you to break it down, getting the exact root. So for instance, if you have the square root of 40, the square root of 40, when you break it down, is literally 4 times 10. And 4 is a perfect square, which is a 2. So when you're doing your answer, you take the square root of 4 out as a 2, but you leave the 10 inside because the 10 is not a perfect square root. So the exact answer for the square root of 40 is going to be 2 root 10. If you have a square root of something squared, the square root of anything squared is what's inside. So the square root of 14x squared is 14x. You can also see this written this way with the squared inside, and that would still yield the same answer, 14x. One other way you may see it is in a multiplication problem like this, where I put the square root of 14x times the square root of 14x. The answer to this is still 14x. Now let's look at variables. Let's go back to our root 25, but this time let's say I have x to the 4th. Now remember from what I said before, I'm looking for 2 of something to take 1 out. So 25 is 5 times 5, and 4 x's is x to the 4th. So when I'm looking at this as a whole and I'm grouping things in 2, the group of 2 5s comes out as 1 5. This group of 2 x's comes out as 1 x. And this group of 2 x's also comes out as 1x. Notice how there's nothing left under the square root. That means this is a perfect square. So whatever came out is all multiplied on the outside. So the answer to this would be 5x squared. Let's try another one. The square root of 25, x to the 4th, y to the 6th. So we already did the 25x to the 4th, but I'm still going to expand it out. So it's 5 times 5, 4 x's, and 6 y's now. And remember, I'm grouping in 2's. Every time I group a 2, 1 comes out. So that's a group of 5, 1 comes out. A group of x's, 1x comes out. Another group of x's, another x comes out. Notice every time I group these y's, I'm taking a y out. So 3 sets of y's come out. There's nothing left inside, so this answer would be 5x squared y to the 3rd. Let's look at what happens if I have a number on the outside previously. For instance, this. If I have 4 times the square root of 40, well, like I said before, the square root of 40 is 4 times 10. This 4 is a perfect square, which a 2 comes out. The 2 that came out needs to get multiplied with the 4 that's already out there, So this answer would be 8 root 10. So notice that when I did this 4, I just looked at it as a perfect square and knew that a 2 came out. But essentially a 4 is a 2 times 2 with 1 2 coming out. Let's look at something where maybe a number doesn't come out. Let's say I have 17 x to the 4th. Well, 17 is just a 17. I can't really do much with that. My x to the 4, however, are 4 x's. I group my x's. One comes out of here. One comes out of here. So in this case, x squared came out, but the square root of 17 is still in there. What if I just had x to the 13th? This is going to equal 13 x's, or I could group them in 2's as I'm doing it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13. So every time I group 2, 1 comes out. So I've got 1, 2, 3, 4, 5, 6 groups. So that's x to the 6th. There's 1 left. Square root of x is still in there. What happens if you have division? When you have a division, let's say I have square root of 25 divided by square root of 36. The property of radicals says that I can take the numerator and the denominator and separate it out, especially if they're perfect squares. So the square root of 25 is 5, and the square root of 36 is 6. So the square root of 25 divided by 36 is 5/6. If you've got the square root of 1 divided by 64, and let's say it's negative on the outside, again, when I split this up, the square root of 1 is a perfect square, and the square root of 64 is a perfect square. So this is going to be negative 1 over 8 for that answer. Sometimes it doesn't work out where everything just is a perfect square. Let's say I have the square root of 5 divided by 16. Again, when I split this apart, square root of 5 over square root of 16, nothing happens with that square root of 5. However, with the 16, that is a perfect square of 4. So that answer would be square root of 4, or square root of 5 divided by 4. Let's say I have a larger number, like 3 times the square root of 225. If I use my calculator and do the square root of 225, it comes out to 15. So this is going to be 3 times 15. Because the 3 is on the outside, the square root of 225 is 15. So 3 times 15 is going to give me a 45 as an answer. So my suggestion is to try your calculator first. If you don't have the decimal number, then it is a perfect square. But if you do have a decimal number, you'll have to break it down to its primes. Let's try one more. Let's do square root of 500. Square root of 500 on my calculator is not a perfect square. So what I'm going to have to do is figure out, how do I make a 500? A 500 is made by multiplying 50 times 10. And now what I'm going to do is break that apart. And I'm going to be thinking of perfect squares as I'm doing this. 50 is going to be 25 times 2. And 10 is 2 times 5. Notice between the 50 and the 10, the way I divided my numbers up, I do make another perfect square. So I have the 25 as a perfect square, which is a 5. 2 times 2 is a perfect square of 4, so a 2 comes out. So 5 times 2 came out of that, so that's a 10. And then root 5 is left behind. What I could have done is I could have broken this down right off the bat to, let's say, 100 times 5. So if I noticed that 500 is 100 times 5 and 100 is a perfect square, I would have got my answer right away. So again, it doesn't really matter how you break these numbers apart. you still will get the same answer as long as you bring it down to the final point. Let's say I have a division problem that maybe says 25 x to the 13 divided by 49 x to the 8th. So if you recall, division of exponents is a subtraction problem. So essentially what I have is 25 over 49 and x to the 13 minus 8, because that's how I do division of exponents. That's going to be x to the 5th. So this is x to the 5th. So now if I break that apart, let's say I do 25 x to the 5th over square root of 49. And I'm putting the x to the 5th in the numerator because there are more x's in the numerator to begin with. So when I do the subtraction problem, they stay in the numerator. So the 25 is a perfect square. It's 5 times 5. My x to the 5th is 5 x's. The 49 is 7 times 7. So in the numerator, a 5 came out, 2 sets of x's. So again, 1, 5, 2 sets of x's. I still have an x in there. And then out of the denominator, a 7 comes out. So this answer would be 5x squared root x divided by 7. This is one way you could write it, or you could also write it this way: 5x squared divided by 7 times the square root of x. Either way is fine for writing it.